This video is for the questions of the day, week 4. Number 1, it involves a one-step equation over here, and then substituting your answer in for r over here. Or at least that's one way to do it. You could divide both sides by 3 and end up with r is equal to 6, and plug that in, and then you have 6 times 6 plus 3, and get 39. Also notice, though, that 3r and 6r have a common factor, or you can get to one from the other. So if I start off with 3r is equal to 18, and I double both sides, suddenly I have 6r is equal to 36. And if I want to figure out what 6r plus 3 is, I can add 3 to both sides, and then 6r plus 3 is equal to 39. And this method works too. Number 2, runaway fractions. Or, just remember that when you are adding or subtracting fractions, you have to have the same denominator. So here on the left, 9 and 9 already works. I'm pretty much just taking 7 minus 4, and this simplifies to 3 over 9x. On the right, 4 and 12 are different numbers. You might notice that if I multiply 4 by 3, I can get to 12. So a strategy is to change this into twelfths. I tripled the 1 and I tripled the 4. It's the same fraction, just a different look. And now I can add them together because they have the same denominator. So 3 over 9x is equal to 8 over 12. There's this nice little trick on the calculator where you could take 3 divided by 9, enter, math, enter, enter. Or 8 divided by 12, enter, math, enter, enter. And that gives you the simplest form of the fraction. If you simplified those fractions, you would get 1/3 and 2/3. So, if you thought about this like a traditional one-step equation, you could try to divide by 1/3, which is the same thing as multiplying by 3. But you could just think of it as 1/3 times what is equal to 2/3. And that's why x is equal to 2 here. Number 3, the number of states that joined the United States between 1776 and 1849, we'll call that this, is twice the number of states that joined between 1850 and 1900. So I'll represent that this way. Whatever number existed here for states between this range, if I double it, I'll get this one. The problem goes on to say that 30 states joined in this range here. So they want to know, what is x if x states joined between that range? So it just flips it around, which you can do. And our answer is B. If you weren't sure if you set up the initial equation right, you could plug in some numbers, like plug in 10 for one and 5 for the other. And does that say that this is twice the number of that when you multiply by 2? And are they equal? If they are, you probably set it up right. Number 4 comes from geometry when we cross-multiply proportions, or at least that's one way to do this. So cross-multiplying means I take the top of that fraction and multiply it by the bottom of that fraction, and I set those cross products equal to each other. So 5 times the quantity, x plus 20, is equal to 15x. And I think it's helpful to keep that inside parentheses so that I distribute correctly. So then I have 5x plus 100 is equal to 15x. I might then subtract 5x from both sides. And eventually I get to x equals 10. So they want to know, what is the value of x over 5? So I'm going to take this whole thing here and plug it in. 10 divided by 5 is 2. And I'm done. I suppose you could try to work backwards from this and plug in the different values and set each of these equal to x over 5. And if you solved each of these for x, we would get 50, 25, 10, and 2.5. And I could plug these in into this original equation and see which one of these is true. You'll get the same answer, that if you plug in 10, 5 over 10 is equal to 15 over 30. None of the others will work. Number 5 is a system of equations problem, and for every systems problem, there's 3 possible scenarios. Probably the most common is the solution is where the 2 lines cross. So here the solution would be 1, 3, when x is 1 and y is 3. That's when it's on both lines. Another possible outcome is to have no solutions, because the lines never cross. The slopes are parallel. Either they're both horizontal or vertical, or they have different intercepts but the same slope. In this case, you would say that there is 0 solutions. And that's kind of what we're looking for here. We're looking for the same slope. But we'll come back to that. The third possible outcome here is that two lines are sitting on top of each other, and there are infinite solutions. So you have one solution, no solutions, or infinite solutions. They want to know about none. The only way that happens is if the lines never cross. So they have to be parallel lines. And just like these in red and blue, parallel lines have the same slope. So I might solve this bottom equation for y. I could add 5y to both sides, for example. Then I might subtract 7. And finally, I might choose to divide by 5, all three terms. So it's kind of backwards. Instead of y equals mx plus b, I have mx plus b is equal to y. But my slope is 4/5. So the question becomes, what number can I plug in for k here so that I have a slope of 4/5? So I might solve for y just like I did in the other problem. Add 3y to both sides and subtract 4 from both sides. I could have kept the negatives and done it differently. I just moved the 3y over to avoid negatives. And then I can divide by 3, all three terms. And the slope of this one is k over 3. So what I'm trying to figure out is, when will these two be equal? When will 4/5 be equal to k over 3? So if we think about common denominators, I might try to convert to 15ths. I could triple this one, and I have 12 over 15. And if I multiply this one by 5, I have 5k over 15. So I can get rid of the bottoms now and just say that 12 is equal to 5k. And if I divide both sides by 5, I get that k is equal to 12 over 5, which turns out to be A. Number 6, which of the following is equal to a to the power of 2/3 for all values of a? So what's important to note is that when we think of like the square root of 4, what this is really saying is 4 to the 1/2 power. That's the more conventional way to write it here on the left, but these two are equivalent. And what that means is we're going to take the second root of 4 to the 1st. It's the same thing as just the square root of 4. So the general pattern here is that when we have a fraction in the exponent, the bottom number is going to be our root. That's the number that goes with the square root or the cube root or the whatever root. And the top number is going to be the exponent that goes inside of the radical. In other words, we're going to take the third root of a squared. And that's it. If you understood that property, this is an easy one. Number 7, we have this table of values, and then we're told that we're looking at a polynomial. So if we were looking at a linear function, there's just a slope and an intercept, and that's it. Literally, polynomial means many terms. So polynomials could be linear, they could be quadratic, they could be something more. We just can't divide by variables. But even something like y is equal to 5 is considered a polynomial, because it has one term there, just constants. The difference is they're talking about factors of polynomials. So if we were looking at a quadratic like x squared plus 5x plus 6, it can be broken down into two factors, x plus 2 and x plus 3. If you multiply these factors together, you would get the whole thing. The solutions are whatever we can plug in that make each one of these factors equal to 0. So if I was to plug in a -2, the first factor would be a 0. If I was to plug in a -3, the second factor would be a 0. So those are the solutions to this polynomial, where it crosses the x-axis or where the zeros are. So f of x is kind of like the y-axis, so I'm looking for where the zeros are. And it's when x is 4. So my polynomial could have a bunch of factors, but I'm pretty sure that at least one of them is x minus 4, because when I plug that 4 in, I get a 0. So I don't know what the other ones are. They could be x plus 7, x minus 2. There could be a whole bunch of them. There could be just a number in front of them. There's lots of different options. It doesn't really matter. The point is one of them is 4. So that's why the answer is here. It should kind of be the inverse. If you have a positive number, then it's going to be minus 4. If you had a negative number, it'd be plus 4. It's whenever you can plug in this number and get a 0. Number 8 asks for the solutions to a quadratic. So there's some overlap with the previous problem. And to make this quite a bit easier, it helps to factor out a 3. So for example, like distributing but in reverse, we can divide every term by 3, and now we're looking at a more standard quadratic. So I like to use the x method to try to factor, but you're going to run into some problems here. So if you take the sum of b, which is just this 4 here, and a product of a times c, which turns out to be 2, it's a math riddle where you're looking for two numbers that if you add them together you get 4, and if you multiply them together you get 2. And no such numbers really exist. 4 times 1, 2 times 2, it doesn't really work. None of those are going to give you 2 and 4. Even if you went -2 and -1, it's not going to sum to 4, so factoring doesn't work. It's back to the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So let's fix that a little bit, all over 2a, and we're going to substitute in these values. So underneath the radical here I have 4 squared minus 4 times 1 times 2. 4 squared is 16, and 4 times 2 is 8. So 16 minus 8, this is going to become the square root of 8, which if you notice is not really one of the answers over here. That's because you can simplify the square root of 8. You can break 8 into a perfect square factor form, 4 times 2. And you can't take the square root of 2, but you can take the square root of 4. And when you do so, and it comes outside of the radical, it comes out as, well, what's the square root of 4? It becomes 2 root 2. And on the bottom here, 2 times 1 is just 2. So now I have two answers, -4 plus 2 root 2 divided by 2, and -4 minus root 2 divided by 2. So I could simplify these. -4 divided by 2 just becomes -2, and 2 divided by 2 just becomes 1. So I can get rid of all that, and my answer becomes -2 plus or minus the square root of 2, which is a. Couldn't factor it, you had to use the quadratic formula. Number 9, if x is greater than 0, what is one possible solution to the equation above? So you could just try to guess and check your way through this. You could try a couple numbers like x equals 0, x equals 1, x equals 2, and go from there. But it tells you x has to be bigger than 0, so let's start here. If you tried 1 cubed times 1 squared minus 5, is that equal to -4 times 1? Well, yeah, it is actually. And then if I tried 2, this would become 8 times -1 is equal to -4 times 2, which also works. So bizarrely enough, the first two I tried worked, and they're both bigger than 0. Sometimes guessing and checking with simple numbers will lead you down a good path, especially when you only need one possible solution and there's a bunch of them. You might be tempted to try to use the difference of squares, where a squared minus b squared can be factored into a plus b times a minus b. But 5 here is not a perfect square, so it's hard to really factor those. That doesn't really do anything for you. So let's instead move the 4x over and go ahead and distribute this x cubed. And then all three of my terms have an x that I can factor out. So this might become x times x to the 4th minus 5x squared plus 4 is equal to 0. So one strategy here is to try to take this middle term and split it. And now it kind of looks like this. I've split it into 2 here. And kind of how I got there is I look at a times c, and that gives me 4. And I'm looking for what are two factors of 4 that add up to the middle term, 5. And it turns out that -4 times -1 will give me a positive 4. And if I add them together, I get a -5. So I can split them like this, -4 and -1. So I factored an x squared out of this first group, and a common factor for the second group is a -1. And notice that once I factor out a -1, the positive 4 becomes a -4. If I was to go back and distribute it, then it would end up positive, so that's what I want. So we have this same term, x squared minus 4, that shows up twice. So if I rewrite this, it looks like this, because these are the same term. So x squared minus 1 can be combined. And if I use the difference of squares to factor these, now I have all my possible answers. X can be 0. X can be -1. X can be 1. X can be -2. And x can be positive 2. They only wanted the solutions that were bigger than 0, so that gets rid of or eliminates these from contention. Guess and check was a little bit faster though, don't you think? Number 10, in the quadratic equation above, a is a non-zero constant, and the graph of the equation in the xy plane is a parabola with the vertex CD, which of the following is equal to D. So a parabola might look like this. And it turns out we can use the zeros to figure out the vertex, because the zeros are symmetric around the vertex, which is going to be the lowest or the highest point. So if we could figure out the zeros of this graph, for example, we can figure out the vertex by taking the midpoint of the two zeros. -2 and 2, the middle is 0, and that tells me my x-coordinate. And from there I can figure out the y. Or if I had a parabola that opened down and my zeros were here at -4 and 0, if I took the midpoint, I know that my x-coordinate is going to be here at -2 for the vertex, which would be the highest point here. So my two zeros are going to be 2 and -4. And those are the numbers that if I plug them into these factors, I get 0. So if I added these two together and divided by 2 to find the midpoint, I'm going to get -1. And that tells me that c is going to be equal to -1, which is very helpful for finding d, because c is my x-coordinate. So I can plug in -1 for x and solve. And if I wrote it out, y is equal to a times the quantity -1 minus 2 times the quantity -1 plus 4, I could also just replace y here with d, because it's the y-coordinate after all. So if I simplify a little bit there, and then I do some multiplication, I get that d is equal to -9a, which is the answer right there.